Okay, everyone, here we are with the ice cream again. It's getting hotter, so ice cream is great. Actually, it's kind of been chilly here in Tempe. But regardless of that, and I don't really eat ice cream, but we're going to do something a little different here. As you remember from the book Multiple Regression, what this is. And we're going to talk about a few different things with this because I know you are familiar with ice cream. So basically what we're going to do here is create a little multiple regression. Remember then Aunt Tilda, that's the dependent variable first, the consumption, and then let's do income plus price plus temperature. See what we have here, and then we get a summary of M. Okay, now everything you knew. Now remember, as the book said, the F statistic here, kind of a global statistic, we have a very significant correlation of these variables with the p-value being E07. So I mean, that's like, that's 0.000 to the 10th, 2. So that's very low, under 0.05. But we have something interesting here, that income now is 0.00899, and you see the two stars indicating, remember stars, I'm from Boston, indicating that this is significant. But we know from our earlier stepwise, it's not really stepwise, but it's the same logic. That's why I ask a question on it. It's basically taking these individually because something is up here. So let's just do M1, right? Because we're going to do another one. And then we're going to do the same thing, but just tilde, just income. Now we get the summary. See if there's a correlation between these two and to see if they're significant. All right, we're seeing it's not significant. So what's happening here? Like I've mentioned in other videos, that's why the adjusted R-squares, sometimes, you know, the goal is to be a little more punitive if you add these different variables, independent variables, because they kind of push up the correlation. As you can see here, the adjusted, because we used a number of them, adjusted is always lower than 0.7, which is very good. Then you have around here 0.68. So by adding more variables, we would look more at the adjusted R-squared. So we're not saying that there's no correlation here, but what we're saying is individually, is income correlated? And it looks like it isn't. That's why you basically do the stepwise. It's the same logic that I was doing kind of before. We're not going to do the stepwise here, but I want you to be conscious of the fact that sometimes these, and it could be autocorrelation, multicollinearity. I've been reading about Simpson's paradox, not Homer Simpson, but a statistician Simpson. And, you know, we're not going to get into the exact why, but this happens, and there's so much theory, there's so much literature and material that we can sift through, very erudite literature on why this happens. And that's why I gave you in the book like that, autocorrelation is income possibly correlated somehow with another variable or something like that, but we're gonna get it. You can get into that later in a stats 2 class, because the goal I want to do next is going to be the GLM function and over, etc. But I want you conscious that this is obviously a problem, and that's why I was doing just the simple correlation test first. So you do like consumption, income. Okay, 0.04, that's not that great. It's not bad, but it's not great. I mean, obviously it's in the point, but then you do the correlation with, like we know, temperature, and you basically have, remember when you do these quick correlation tests, it doesn't have to be the X first or the Y first. In this case, it's X, the independent variable, then the dependent variable. But then we get a very strong correlation. So you compare those 0.047 and then 0.77, which is like just about 0.8, is very correlated, you can see in this. Just for a quick look, so we have to be conscious that some of these, if we're running multiple regressions, sometimes one variable will look as if it's significant, statistically significant under p0.05, the p-value, but it might not be exactly significant on its own. And I also wanted you to be aware of another thing, the least squares regression line. So let's say, for example, if I did M2 and we just did the LM function, linear model here, and did consumption and temperature, as we know, we know what it's going to be. It's going to be statistically significant. But then we want to plot this, and I'm going to get into that plot right now. So remember, when we're plotting just a regular plot, this isn't ggplot2 or anything like that, but I'm going to do colors, and I think that R itself has pretty decent colors and everything else, and then you can add ggplot2 and all these other packages to make it look even better. But just generally speaking, the plot, as you can see, it says XY. So basically, what's X in this? Temperature. Then what is the dependent variable? Consumption. And then let's start adding things. What's the X lab? What are we going to call X lab? Let's call it temperature. It's called the Y lab. What do you want to call it? Consumption. And we'll call the main thing just ice cream. You can call these things anything. And this is good to know for your paper, which you do have to run something in it. So you basically have ice cream. But then let's try something else called PCH. Let's say number 12, and you're going to kind of notice this stuff. And then we're going to do, let's say, colors. So C, and I'm going to send you something out on this. C, oops, forgot my color. C, blue, and what other color is good? Green. Let's just do this. So let's see what we basically have if it works. And it does. So look at this. This is my thing. Consumption over here. That's the Y lab. Temperature over here. It's named ice cream. And now these are obviously the units of consumption that we're measuring. You can do anything. I don't particularly like those colors, but you can do different things. The PCH makes it able to do, let's see this one. Okay, now those are squares, but there's a wide range of different things you could actually do. Make it kind of cool. Look at that. I think that looks like the Star of David. So there you go, the Star of David we can use. There's other things. I'll just use the regular 19, and that's just the boring kind of circles filled. But look at the colors. The colors change. So that is very interesting if you want to kind of make your graphs a little nicer. But there's something even more important in here that we're going to quickly do, and that's going to be the abline function in this. So basically I did the plot. This is a simple plot with all that, the X lab, the Y lab. You can go back and kind of trace it. But now we're going to do abline. What did we call it? I believe this right here is M3. That's how you do it. And then let's do a color. What kind of color do we like? Let's call it red. So we want to do red. And what you have here, oh, my ab line didn't go through for the color. Did I do, oh, it must be M2 then. All right, let's do M2. That was it. All right, there it is. So it was basically called M2. So if you notice way up here, it's called M2. That's just the LM consumption temp. So what I did, there's many roads to Rome. This isn't the only way you can do it. But there you have the least squares line basically fitting right in the middle of these units, basically the variables here, where this is all consumption, that's temperature, as you can see, going up, right up. The more temperature you get, the more ice cream consumption you get. And I even did it with these kinds of different colors of the unit. And ice cream obviously is the name of it. Consumption is measuring here, temperature here. So that's kind of cool. I want you to be able to do these kinds of things for your paper so you can do something really cool. So that is about it. Now I want you to go back, kind of look at what I did, see if you can do it for your own graphs. But these graphs you can make a little nicer, and you can do just about anything. Let me see, turquoise. I can never spell turquoise, so I like turquoise. So you can do different colors, and I think I did turquoise once. Let me copy and paste it. And turquoise would be nice, so let's do that. Remember, you can just press up. You've got red. Cool, it's turquoise. So you can do all these different colors. And I believe, if you correct me if I'm wrong, although the ab line will disappear, if you go back here, you can even add different ones. Let's see if I can add red. Yep, so it went in with red as well. So you basically get all these different colors, and then go back to this. And then you put it back, and there you go with your regression line. So this is kind of a way to cleverly do this, and I know you're clever people, and I want you to do something, you know, it doesn't have to be great, but for your paper. So without further ado, please leave any comments in community forum. I hope to hear from you people. And if you want to bounce off an idea for your paper, just, you know, email me, or even write it in community forum, and maybe other people can benefit from your question of the final paper. Take care, everybody there, and stay safe.